Hello friends, very good afternoon. Myself Dr. M.H. Annaya, your tutor in the subject engineering drawing. And friends, in this video, we have been given with the orthographic views of a simple casting, a product or a component, and we are required to draw the isometric view of the given object by noting down the dimensions from the given front view and top view. Friends, basically, you all know that to construct or to draw the isometric view or isometric projection, any of these two, you have to construct a box in isometrics that is taking the lines of projection at an angle of 30 degrees to the horizontal. And if it is isometric view, we have to take the actual dimensions as they are and construct a box here. Friends, here, let's see what are the overall dimension. It has got a length of 70 and width of 50. Length is 70. I have marked here. Width is equal to 50 millimeter. And the height is obtained from the front view, that is 50 millimeter. So I have constructed this box with height 50, length 70, width is equal to 50. Friends, let us see what are the slots or cutouts or the projections from the surface of this platform. Friends, here you can see that there is a rectangular cutout on this face which is shown by a dotted line, and it has got a length is equal to 15, width is equal to 10. So 15 by 10. So friends, here before that you got a platform of height 20, width is equal to 50. And friends, I have marked 20 millimeter here on the vertical axis and on all these four sides. 20, this is 20 and 20, and I have marked. And there is a rectangular slot of length 30 and height is equal to 10 cut throughout, and that is represented by these two dotted lines in the component. Friends, I have shown them here by a rectangle of width 30 and the height is equal to 10. This is 10 millimeter height. That can be seen here in the front view. There is a slot cut throughout. And friends, again, on this platform height 20, there is a tapered portion. This is a tapered portion that appears as a rectangle in the top view. This has got a width 15 and height. The height can be seen here in the front view. The width can also be seen in the front view, and that is represented by a rectangle. Again, there is a flat surface of width 15 and the length is equal to 25. So this is the other dimension. So this is a flat surface, this is a tapered surface. Where is our friend? That comes above this platform of height. This is 20, this is 30. So above this platform, there will be this projection or a protruding part, a part which is projecting outside or above the top surface. Friends, let us start this projection by marking this in the top face, this rectangle. Friends, that rectangle has got a dimension 15 by 25. So along this is 15 and this is 25. So friends, I will mark it here 25, and in the front view you see it as 15. So friends, that appears as a rectangle here. So hence I am going to mark it here in dark line. So I will explain each one of these slowly so that all of you will be able to follow. And this I have constructed. That is a representing that rectangle. That rectangle we have got, friends, here. And adjacent to that rectangle, you have a tapered face. So, friend, the tapered face is here. Friends, this tapered face here has got a width. This is 15. From here to here it is 15 when you project. From here to here it is 15. And there is a taper. And since it is at this end, we are going to project this downward and join these. So friends, this represents the tapered surface or the part that is protruding outside or above the platform having height is equal to 20. Friends, after that you can see here, this is the platform you have got. So that platform I am going to draw by visible lines. This is one line, the second line, the third line here, the fourth line. So I have shown all the four edges of the top surface, friends. So this I have completed. This flat surface I have completed. This flat surface. And friends, let us mark this slot of 15 by 10. So friends, is exactly in between this 50, exactly at the center of this width. You have a slot cut out, and that slot has got a dimension 15 by 10. So friends, I will turn parallel to the base 10 millimeter, again here 10 millimeter, and parallel to this left edge we are going to have another line. This is 15 and this is 10. Friends, this is a vertical slot, this is open at the bottom. So I am going to show by drawing this by vertical lines like this. So after this you have this portion, let me complete that. And again this side we have to complete. Friends, this is the slot you have got. But remember friends, this slot is only up to here. So what I do, to show this edge, I should write a vertical from there and a line parallel to this or parallel to the edge here. I am going to show like this. Again a horizontal line. So there is a slot which is rectangular in form or in shape, that is there exactly in between these two, and this is having a dimension 10 and this has got a dimension 15. Friends, we have completed this protruding part. This slot we have completed. Finally, we are left with a rectangular slot which is cut on this 70 millimeter side exactly in the center. This is exactly in the center of that. So I have locate the center. Then on either side take 15, 15, and height is equal to 10, and I am going to have what is called a rectangular slot that is cut along this face. Friends, this vertical edge I am going to show here. Again, this vertical edge from this corner. And friends, as you see, we have completed everything. But since this is a slot, I should write a line parallel to this through this. So this indicates that there is a slot cut throughout the 50 millimeter side depth. Friends, I hope we have marked and completed all these, and this figure will give you finally the isometric view or isometric drawing of the component whose orthographic views are given. But friends, to make this drawing look beautiful after completion of all these, it is better or best to say that we remove all these unwanted lines. Unwanted lines means all these construction lines are to be removed so that you will have a clear or a better picture of this. So friends, I will remove all these unwanted lines here. You can see this is getting a better view compared to the one we had with all these construction lines. But if you want to retain these construction lines, friend, you have to show it by very thin lines, just visible to you. You can retain, there's nothing wrong, but to get a clear picture of this, we have to remove all these unwanted lines. So friends, I have removed all these unwanted lines, including this dimension here. So friends, you can have a look at this, and this is looking better than the figure we had with the construction line. This is how it looks, friends. So let me darken this, and all these, friends. And this will give you the isometric drawing or isometric view of the components whose orthographic view, that is the front view and top view, are given to us. And if you are marking here, this has to be marked as XY, and in the first angle projection, this is going to be VP by HP. And here, to get this front view, you have to look in this direction. I will simply call it as F. And in this view, if you see, you will get the end view or left end view. And if you see from the top, from this end, you will be able to get this. Friends, we have constructed or made the isometric view of the component whose orthographic views are given. That is to say, in other words, we have used all these dimensions as they are: 70 length, width is 50, height is equal to 50, and all the dimensions are transferred onto this with a scale of 1:1 in the sense. So whatever the dimension you find here, so all the dimensions marked on this are the actual dimensions, or the figure is drawn to a scale of 1:1. And if you are asked for the same orthographic views to draw the isometric projection, just remember isometric projection, then you need to make use of what is called an isometric scale, wherein all these dimensions of the components are to be multiplied by 0.815. For example, a dimension like 50, if you multiply by 0.815, it will be around 42. So instead of marking 50 here, you have to mark it as 42 millimeter. Likewise, friends, if it is a slot having 30 into 815, about 25 mm, that is, the isometric projection construction is exactly similar to the isometric view, excepting that the dimensions given in the orthographic views are to be multiplied by 0.815, and then for that reduced dimension you have to draw this isometric projection. Friends, I hope the presentation was interesting, and please go through the complete video, my dear friends. If you like this video, do share this video with all your friends without fail. And in case if you have not subscribed to my channel as on now, as on today, please subscribe to it without fail. Your subscription will act as a sort of motivator for me to make more and more videos on the subject engineering drawing. I thank you very much for watching my YouTube video. Have a wonderful day.